Alright, welcome back to another episode on my Project Pan series. So basically in this series, I'm building myself a panhead for as cheap as possible. I don't make a lot of money, I don't have a lot of money, so the only way I can build one of these things is buy all the cheap parts that are fucked, fix them, and put one together. So it's exactly what I've done here. So this is a bit of a fast forward from the last video we did. The bottom end is completely together now. The problem is that I work on my shit between customer stuff. So it'll be late at night or fucking first thing in the morning, waiting on a part, this and that. So it's pretty hard to film all these tiny little sections and then put them all together and make something make sense. So basically I've just done a heap of fucking pan, flat roller bottom end. So it's all the same shit basically. I just had to put this thing together. If you're on my Instagram, you would have seen I post a heap of photos and videos on that. So if you're not already, I'll put a little banner here. But basically, you just got to put these cases together with all your bearings and everything together, nice and dry. Measure your lash, so that's how much your crank goes back and forth. So I did all that, and because these are custom machined flywheels, these are 3-piece Evo flywheels that I have machined into early taper drive and early pinion shaft flywheel. I had to go through and measure the lash. I actually came up perfect. I got 100 thou washer on both sides and I've got about 15 thou float. So that's good enough for us. So basically I have this bottom end all together. Look at this, turns over like absolute butter. It is fucking super, super nice. So the other thing I did off camera, I went through and I test fit all my gear case stuff. So I bought a new cam for this thing. I just bought 2 cams when I did Travis's motor. I bought a J grind for this thing. I don't want this thing to be a pig to start. Yes, it's going to have a heap of stroke and a heap of compression. I should probably have an A grind or something on it, but I also want to ride the fucking wheels off this thing, and I don't want too much lift in my valves, because the more lift you put in the valves, the more highly strung you are making the components. So pushing the valves further means you're pushing them faster and putting more strain on all your bits. So your rocker's going to have more strain on it. Your valves are going to have more strain on it. Your springs are going to have more strain on it. Your lifters are going to have more strain on it. Your cam's going to have more strain on it. So if you want an engine to run forever, you make it as stock as fucking possible. That way, you don't have this huge cam that's pushing all this lift and you've got so much more shit happening in a short period of time. You got to remember how fucking fast these motors turn over. And there is a fucking lot happening in that time. So that is why I just went with a smaller sort of a cam, just so it's nice to start when it's hot. It's easy to start. I can breathe on this thing and get on it and go, and I'm not straining all my lifter components and push rods and springs and valves because I want to go fast. I generally just want to sit this thing on the highway with all this stroke. It should piss it in. So it's more stroke, more torque. So basically where I'm up to with this thing, in the last episode we spoke about our barrel heights. So a little trick back in the day to get yourself some more compression using a stock piston, they used to shorten the barrel. So shortening the barrel obviously brings the piston closer to the head and ups your compressions. I sort of don't want that because I'm running a 4 1/4 stroke here, so 1.25 a stroke. I've got to use an 80 cube piston. So a late model shovel head cone shovel is an 80 cube, right? So they have a 4 1/4 stroke, 4.25 quarter stroke, and they've got a 3.5 inch barrel. Well, it's just under 3.5 inch. So that's basically what I've got here. So I have a panhead barrel that is all the way out to 60 thou, and that's how you put a stock 80 cube piston in this thing. And because I've got 4 1/4 stroke, the rod will come up higher and it'll go down lower. So with an 80 cube shovel, obviously I'm just using a stock piston. So the deck height is shorter and the skirt is shorter. So that when the piston comes down the whole way, it misses your flywheels at the bottom. And when it comes up the whole way, it doesn't punch into the head. So in the last episode, I went looking for some different barrels because these barrels have been shortened. So my piston comes too far above the deck height. So it is fucking hard to find panhead barrels these days full stock, let alone the size you want. So all the barrels I could find were either on size. I bought some from down in Melbourne, I think, and they measured good. He measured them for me, but they were tapered. So to get them to the right size, they would have been 80 or something thou over, which you can't get. And then I could have got a 80 cube piston to fit that, but they get super thin through here, which I was talking about in the last episode as well. It just breaks the top of the piston off, which I don't want. I also don't want to sleeve one, because having two materials in there makes it weak as well. So I want it original, not sleeved, and 60 thou over. So these barrels I got off my buddy Jesse are 60 thou over. He had pistons for them, but I'm going to run my 80 cube shovel pistons because I need to for deck height and skirt height. The only problem is that they have been shortened, like I said. So I'm going to go through and work out stroker plates. So my buddy Joel has a laser cutting company. He just laser cuts me stroker plates, whatever size I want. You can just buy a stroker plate from somewhere. They're usually like an 1/8 inch or a 1/4 inch. They're quite big. I want to run some good compression in this thing. So I want to measure the compression and work out what size stroker plate I should get to hit my desired compression. So basically, to run a stroker plate, it's just a bit of stainless like this, right? And the bit of stainless will get sandwiched between two gaskets. So I have yet to buy another gasket kit, but I need to buy a top-end gasket kit for this anyway. But luckily, I have 2 spare gaskets. So I can use these and the gasket kit that I buy, and then I will have a gasket top and bottom of this thing. And that's how we get our thickness. So in this episode, I want to go through, work out a compression ratio that I want to shoot for. I would really like it around the 9:1, but we'll have to see because of piston design and pan heads and stuff, we might not get that. So I want to see how close I can get these pistons to the heads without them hitting, obviously. The other thing I want to do, I want to get those heads fitted out, ready to slap on. So I've got brand new lifter blocks for them. I've got all the studs, screws, all that shit. I want to get those heads together so that when I work out my desired stroker plate size, thickness, and I can get Joel to cut that, and then in the meantime we'll get them going, and then once they get those plates I can fucking slap this thing together. I've already got all the rings gapped and all that shit, so I literally just need to get that done. The other thing we can probably do, like I said, I have all my gear case stuff sorted out, all ready to go. So I might as well put the oil pump and all that sort of bullshit on, get this whole bottom end done, and then we're just waiting on that stroker plate, and then we can chuck the whole fucking thing together. I've got a bit of motivation on this thing. I'm just putting Travis Tuckerman's engine together, and it's sort of giving me a kick in the ass. I want to get this fucking thing together, and that's going to give me motivation to put the frame and everything together that I've been stockpiling parts for ages. So anyway, let's get into this and start measuring some shit. All right, so the way I sort of want to think about this, we want to have some gap between the piston and the top of the head, right? So yes, there's a couple of ways you can do that. So the first way you could do that is with just like your kid's Play-Doh or something. You put it all together and then you put a little bit of Play-Doh around the top of your piston here or in your head, and you can push the thing all the way up and then take it apart, and you can section your Play-Doh and measure it, and that'll tell you how much thickness. The other way I want to do it is basically clearance is clearance in a motor, right? And when you adjust your push rods, right, when it's cold, you do it tight, right? And then when it gets hot, it loosens up. So your barrel expands and your head gets further away. So when it's in running temperature, it'll actually have more clearance. So what I want to do, basically, I'm going to go with, I want the thickness of my head gasket here as the clearance between the piston and the head. So what have I got there? I've got, let's say 45, 50 thou. So that is fucking heaps. So I want to measure this up, see where, so I want to put this together, right? And then I'm going to shim it up to the point where I can put the head on the barrel without the head gasket and it just misses. So then we know when we put the head gasket in, that's going to be our clearance. So I want to do that and then work out where the piston is in the barrel and then measure our compression ratio. So hopefully that'll be pretty high. So basically what I want to do here is, obviously because we're running said spacer, we've got to run two base gaskets like I said. So I've got a 35 thou base gasket. This is the biggest one that Joel cut me. Joel cut me some of these stroker plates for another job that I did a while ago. So what I'm going to do, so put one of the base gaskets on, right? I've only got a pair. So this is a front gasket, but the thickness is, going to be good enough for us. So stroker plate, just like that. And then other gasket. Yes, it's a front gasket. It will fit and the width will be correct. So let's go with that. And then we'll put our barrel on, right? So barrel on. If I put it on the right way, you're fucking spastic. Just like that. So piston goes all the way up there. You see it at the top there. So that is quite a lot. So the other thing I've thought about doing too, because these for a 80 cube shovel, right? This little dome is going to be a little bit different. So I think a Panhead's a bit more of a dome in there. So I can always put the piston in and take a little bit off this edge. I'm pretty sure that edge is where it knocks. So let's put our head on, like I said, and we want this to miss, which I don't think it's gonna. That's quite a lot of protrusion there. Yeah, so see it hit there? I haven't even got fucking nuts on the base yet. So let's put some nuts on this just to hold the barrel down a little bit. Yeah, they say with your barrels, if you take 50 thou off your barrel with a stock piston, it'll raise your compression by 1 whole point. So I think a stock's usually like 7.5 or 7 to 1. I'm pretty sure an FLH was 8 or something. So if you were to take your 7, take 50 thou off your barrel with a stock piston, you'll go to 8. So that's why they fucking used to do it. But when you start doing weird stuff like I am, that gets a little bit annoying. So like I said, see, that's a big hit there. So what I want to do, I want to sort of see where it's hitting as well. So let's do this. I'm just going to see if I can get a bit of a witness on the piston and on the head here. Not really, sort of. The other way we'll do it, get a little bit of grease and we'll put it on said piston, and then where it leaves the grease behind, we know that it's hitting. But as you can see, the thing is protruding quite a bit, so I'm not surprised that this is hitting. It's a little bit more than I was expecting. So if I can't sort of, let's put that on there like that. Yeah, so it sort of hits right on that. Fuck, it's got like a sharp radius on it, on the piston. I think I might put that in the lathe and take that off. So it's got this big sharp radius here, and I would say that's for a shovel. That'll fit in there nicely, but it does not fit in there nicely on a Panhead like this. So the other way you can do it is just dump it in like that. In saying that, oh, it does hit a little bit. Yeah, I think I might knock that edge off, and then we'll get a heap more clearance. I was thinking about machining the heads, but fucking piston's going to be easier to put in the lathe and spin real quick, and just take that edge off. So this is the edge I'm talking about. So if I was to just, there's heaps of meat in there. See how it doesn't do anything? There's just a big radius there. So I can just probably just take that little cut off there just with a 45 or something. So I'm going to go through, just do that. Yes, I have balanced this and everything already, but it's not going to fucking matter. I'm going to be taking off a fucking tiny, minute piece, and it's not going to matter at all. So I'm going to go through do that quickly, and hopefully that means we can get a bit less of a fucking spacer under there. There's quite a lot of spacing going on, so let's go have a look at that. All right, so after a few minutes of brainstorming here, so here is where I'm at, right? So these are obviously my pistons. I was talking about just taking this little edge off here, but thinking about this, every time I go and get heads done, right, they machine this face here and make it flat again, right? And I would really like to have a tool to do that. So if I was to make a tool to be able to face my head gasket area here, that tool would also allow me to cut this edge a bit so that this piston fits in there a bit better. So you can see that it sort of hits on that edge. So if I had a tool to hold this head in the lathe and spin it, I would be able to just cut that little edge off there and the piston would go heaps further into the head. So this got my brain ticking. So over here, I sort of thought about how am I going to make said tool. So basically what I got going on here, I can grip the inside of the head with my jaws, right? And that will show me where the center is. So if I was to spin this, so we know the center is somewhere here of the head, because obviously to machine this side, I need to hold onto that side, but I need to find the center on this side to be able to spin it around and hold it in the chuck. So what we're gonna do here, I'm gonna make a plate that bolts to where all 4 rocker bolts are, comes in and goes like this, right? And with that plate, then I can spin it with this, use my center to mark where this center of the head is on the top side. And then I'm gonna weld, just a bit of stock on there, just a bit of round stock onto the plate, and then I will machine it. So I'll come here, machine said little bit of stock here, and then what that's gonna do is that's gonna make it perfectly center so that when I turn it around, I can put it straight in the lathe and spin it, and then I'll probably put it in the forge ore so I can dial up the other side perfectly. So that's exactly what I'm gonna go and do here. So I'm gonna see if I've got some plate to do this. Fingers crossed I have a bit of plate. I can bolt it on here, and then I can weld my little socket on there so that I can machine it and hold onto it. So let's fucking see how I go. All right, so this is what I've come up with. If you guys want to knock off my idea, more than welcome. Just take a screenshot right now. This is all the dimensions I need and the center of all the holes to cut said plate. So this is what said plate is going to look like. It's going to obviously bolt all 8 bolts, and it's going to come in here like this. And the idea of it is, once I get this cut, I can bolt this to that, and then I'm going to put I've put a 2-inch radius here. I'll probably put a 3-inch piece of stock here. I want this to be fucking nice and solid because we are going to be spinning heads and cutting them. So I don't want this guy to be fucking weak. So if I put a 2-inch radius here, that's 4 inches across here, and then I can put a 3-inch piece, I will just sort of miss these 2 bolt holes here. So then I can just put a center in it and then hold the head and then machine that. And then both heads are symmetrical. So I can just take said piece, bolt it to the front and rear head and do exactly the same on both. And I will be putting this in, obviously I'm going to have a little bit of wiggle room in these holes here. So I'm going to be putting it in a 4-jaw chuck. So I can just sort of manipulate this and then chuck my dial indicator on the front here and on this little edge here. And that's how I will dial it up. So that's pretty well it. I want this pretty accurate and I don't have the material, so I'm gonna get my good buddy Joel to cut this. I reckon I'll cut this out of some 6mm or something. I'll see what he says about 5/16 holes. You can't really go smaller than the thickness of the plate with the holes. So I'll see what he says about that. Even if we have to come through and fix them up after he's cut them, doesn't really fucking matter. So that is it. Unfortunately, I will have to wait for him to cut that. He is a fucking very busy person, so not sure how long that's going to take, but I can't really do this and work out my compression until I have that cut and the heads cut and then this worked out where that's going to be. So in the meantime, we're going to scrap that, wait for this stuff, and I'm going to start putting my bottom end shit together. So let's put this whole gear chest together. Let's put our oil pump together and do all of that shit. And then hopefully by then, Joel has this stuff cut and we can go on with the heads and work out our compression and whatnot. So let me get rid of all this shit and then we'll work out what's going on here. Alrighty, while we are waiting for those plates to my buddy Joel to cut, I have gone through and basically sorted out all of this gear side, bottom end section, whatever you want to call it. In the last few weeks, I feel like I've put like 4 or 5 of these things together. So I skipped putting the oil pump together. You guys know the drill. Spins fucking real nicely with my finger. So that's good to go. Just remember, you put on your this little guy before you put your oil pump fucking gear on. Otherwise, you have to pull it back off. I have done it before. I didn't do it this time. I learned from my mistakes. So basically, I have all my gear chest shit here ready to put together. So basically, I just want to throw all this together. I went through and I polished my cam cover. This is a 4-fin cam cover. I believe this engine is supposed to have an 8-fin, but is what it is at the moment. I'm happy with that guy. It's going to work a treat. So basically, we just fucking throw this thing together, right? So let's fucking start with all our freaking... These guys, actually, I need to get my cam out. I've got my cam in my box somewhere here. So just remember, heaps of fucking oil when we put this stuff together because it's going to fucking turn over a few times before we get oil in here. So you'll always rather be looking at it than looking for it, is the old expression. It goes for more things than one. So basically, look at our nice little... Oh, you fucking idiot. Oh, I've got a fucking ingrown nail on my fucking finger and I keep fucking knocking it. So that spins nicely. Now, I went through and I've already set up all my cam chest. I set up all my clearances and everything. I even went through and set the float on my little bushes here. So what I've got here, I've got a bush that has a T and a bush that has an I. So the T is for our timer and the I is for our idler. So I did that. Mainly you want to do that on your timing side because that's the wrong way. If your timing gear moves in and out with the motor, that's actually changing the timing because you're on a spline drive. So doing that changes the timing. So having a nicely shimmed washer makes a big difference. And I just did it for the idler as well, so it doesn't get any knock back and forth, basically. But I've probably gone a bit ahead of myself here. I need to put my freaking oil pump drive on. So there is my oil pump drive on. And then I have a spring with a fucking washer. So the washer is just so, I think it's just so you can't completely crush, the spring and your timing gear still has plenty of movement. So obviously, this is one of those timing gears that only go one way and it's sprung to push against the chest and make oil pressure for your big end oiling. So I'm going to check all my big end oiling once I put all this together, turn it over, make sure I've got oil going to the correct places. So now that I have that on, let's put my fucking idler back in here. I need to time this, remember. So we have 2 marks on our idler here. 1 mark here that lines up with your timing gear like that. And the other one goes straight up and that lines up with your cam. Doesn't matter if it moves a little bit like that. As I said before, I picked myself up a J grind for this engine. So I have also set the lash and everything already. So I have a washer on there ready to go. That's all sorted. So let's line up our timing marks. So this has 2 timing marks as well because you got to time your breather. So we're going to turn this over again. 2 revolutions should line up again, which it fucking does. Exactly what we want. Line that up, just like that. The other thing you want to watch, I spoke about this earlier, you want to watch that your timing gear isn't proud and hitting on the back of your cam. I've seen that a lot with aftermarket gears. They're 80 thou or something too long and they hit on the back of your cam, which is not the end of the world, but it's not great either. So got to keep an eye out for that. So that's all that. The only other thing we need to do is our freaking breather. So breather is also timed because you want it to breathe at the right time. Breathing at the wrong time will make it huff heaps of fucking oil. So also time, just like that. And I've already set the lash once again, so I have this washer that I ground to the correct thickness. So all this should be right. So a good way to check, you can go 2 revolutions and it all should line up again, right? So let's go 2 revolutions. So 1, that's the wrong direction. Hey, let's go the right direction. So 1, trying to get my fingers fucking caught in here. Alright, I don't know what the fuck I did there, but it's not lining up again. Oh, it does. See, there it is, lines up again. So that's all sorted. 2 revolutions, it all should line up again. So we can let that move like that. That's all good. So we just go along this. I just want to give this one last wipe. Make sure I don't have any crap on there before I put my gasket. As always, we are going to grease our gasket. These might seem like the wrong thing to do, but grease actually makes these things stick and work way better than a dry gasket. A nice moist gasket like this works way better. So it also helps it stick in the right spot. Like your oil pump gaskets, for instance, you can grease them up like this and stick them in the right position. You don't have to worry about them fucking moving when you're trying to put this fucking thing together. So go through, give this thing a nice grease. We don't want to break this fucking gasket either. They're a little bit ginger, so try not to pull on it. Just move your fingers around. So that is pretty well that. Have I forgotten anything? Looks fucking good to me. So push it on dowels first, just like that. Dowel, dowel. I have my little breather screen in here as well. If you guys are running that, a lot of people don't run it. I think it's good to run. It sort of gives the oil a good chance to come out of the air when it goes through the screen. That's the idea of it. So put it on there. I fucking bought a new one in the kit. Why fucking not? So before I do that, let's put a bit of oil on all the snouts of this stuff. Oil on snout, snout, snout. Same in here. It's going to be a little bit before it gets oil, so we want to help it as much as possible. So that is that. Put it on. Should go on pretty freaking easy. Everyone always tells me don't use my hands as hammers. I will regret it. So there we have it. Now, like I said, I already checked all this. So without the bottom end in, before I put the flywheels together, I went through and made sure all this stuff rotated nicely. So we can do the same now. Turn it over, make sure nothing's tight. It's nice, look at that. So get my little screwdriver in there. Where the fuck I put it? Move this back and forth. Yep, that moves. So I'm going to go through, put all of my screws in here, tighten it up, and then when we come back, I want to put my lifter blocks in. I might as well put all the lifter blocks in, and then we'll turn it over and try and get some oil pressure out of this thing, eh? All right, I have my little science experiment going on here. I have my tube going into my pump with oil in it. I just turned it over first, made sure I had oil coming out of my pressure gauge port here. That was all good. Then it's started coming out of my lifter screen. That's perfect. Then it started coming out of my oilers to the top end, that's mint. And then I blocked them up with my fingers and turned it over. And you can see that oil there sitting in the rod. So that oil there in the rod, that is the rods getting oiled. So all the oiling on this thing is working a fucking treat. So that is pretty well the bottom end all done. Like I said, now all I got to do is wait for my buddy Joel to fix up those plates. We can do the heads and work out our fucking barrels over there. And then we'll have a fucking hot rod here. So not sure what's happening next. You'll find out in the next slide, I suppose. All right, so fast forward a week or two, and here we are with our cut plates. Now, Joel cut them like this. I haven't actually double checked the drawing. I think Joel did this wrong. See, I've got this extra bit out. I don't want to have to tell him he done it wrong because he's just going to hate doing my stuff from now on. But pretty sure I had it drawn like that, but I haven't double checked. Anyway, I just had to cut this extra little bit out here because it fouled on the springs, because I want to be able to machine this all together. Without the springs, that would have gone on fine, but this is how I want it. So basically that all goes on. Look at all my holes. They line up freaking spot on. All my fasteners go in here super easy. So I absolutely nailed the measurements. So that's really good. I only made these holes 5/16, so they're bang on holes and they screw straight in. There's no resistance, nothing. So absolutely nailed all 8 holes. So anyway, now what I want to do, I want to bolt this on here tight, right? And then we will put it in the lathe. I'm going to get a rough center here. Not that it really matters. I just want to put a center in it here so that we can measure out here and work out how big the bit of material is going to be. Pretty sure I made it like a 3-inch radius in the drawing. I don't really remember. I mean, a 1.5-inch radius, and it's a 3-inch diameter. So let's have a look. Let's chuck this in the lathe, put a center in it, and then I'll show you how we're going to tack the spigot on here center. That's a little trick. We're going to do it in the lathe. So let's get this done. So I got the thing in the lathe here. You can see I have my center drill in my chuck here in the tailstock. So what we want to do is just spin this so I can get an indication of where the center is. So just spin this around and make sure I don't hit anything, because I'd rather not fuck this head. It's pretty expensive. It's already set up, ready to go. So let's do a bit of... Well, this is going to tell us the center. I also use this to machine it, I think, but that's a good start. There she is, running perfectly true. So there she blows. So I'm going to take this thing out and we're going to work out what bit of material we're going to put here. Righto, so what I got going on here, I need to weld a boss to my little mounting plate here. So what I'm going to do here, when I mount this boss to my mounting plate, when I weld it on, I can turn this whole assembly around and I can hold on to said boss and then spin the whole job the other way around, and then I can machine my chamber. So basically what I got going on here, this guy's just sitting in here. I have just machined it so that, this is just going to drop out. So I have machined it so obviously it's a bit of round bar, so I had to tack this plate on so that I could get a center. So that's basically what's going on here. Will I be able to do this one-handed? Yes, I will. So basically what I'm going to do, I'm going to tighten this up. Oh, well, this is not as easy as I thought it'd be. I'm going to tighten that up like that. See, this can just turn that a little bit, and then I'll put a little bit of pressure on this, and then I can tack this so that this piece is going to be true then. I won't bother machining this while it's in there like that, just because I'm going to put a 4-jaw on here so I can spin it around and then clock my mating surface and my little firing ring in there. So I can clock it up so it's perfectly true. So this doesn't have to be perfect, just has to be pretty close to make life a bit easier. So I'm going to go through and tack this up on there, and then I'm going to take it off and weld it up. And then we'll stick this thing the other way around and start machining our chamber a little bit. All right, so before I go ahead and start knocking out a little bit of this chamber here, I want to do a little bit of a cleanup on my piston. So I've gone through and I've put my 4-jaw chuck in here. Now I'll get back to why I'm using a 4-jaw in a second. But basically what I want to do here, when we put this piston in our chamber like that, you can sort of see the bit that is contacting is this like sharp piece on the piston here. So what I want to do, I want to put this in the lathe and just chamfer that. I just want to put a nice little cut on that and bring it down before I start messing with my chamber, because if I make this a nice chamfer or a radius, it's easy to cut a chamfer or a radius in the top of my chamber here, but it's not easy to cut this sharp edge into the chamber. So I just want to knock them off. I think I'll gain a heap of clearance just knocking that off. But secondly, I have this tape on here. Now I put this tape on here so that the jaws on my chuck here will not scratch my skirt. So the skirt's obviously the bit that goes up and down on the cylinder wall, so I don't want to scratch that with the jaws. Now, lastly, I'm running a 4-jaw so I can set this up. In a 3-jaw, you cannot set the piston up, obviously because it's not perfectly round. So in a 4-jaw, you can put it in like that, and then obviously the outside 2 jaws that are parallel to each other are going to be bigger, and then I can hold onto the pin area with the other side. So I can hold onto a weird shaped piece like this in a 4-jaw, spin it and cut this edge. The other reason I want the 4-jaw is when I go and do this, this is, by the way, I've welded this. No need to weld this the whole way around because you'll just distort it. So this is heaps of weld to hold this. I'm not taking massive fucking cuts or nothing on this, so I'm just going to take little ones. That's heaps. But like I was saying, this holds into the 4-jaw as well, and I can dial it up better. And the 3-jaw is self-centering, so I can't get this inside perfect, but with a 4-jaw I can. I can also dial the front edge and get that perfect as well. So that's why we run the 4-jaw, to do this more accurate stuff. So let me go through. I'm going to dial up my piston in here, and then I'm going to cut that little edge off there. So this is what I'm talking about. I can spin this thing and you see my dial is barely freaking moving. That is what we want. So that's what we can achieve with a 4-jaw. So I'm going to go through, just chamfer this just a little bit, do the same on the other piston, and then we'll sort these barrels out. These chambers out. Right, I can give you a look at this thing now. So I have it in there, round the other way in my 4-jaw, right? I have gone through and dialed it up. It fucking dialed up mint. Check this out. Look at that. So this edge here is freaking bang on. This is our firing edge. So basically what I want to do, I want to come in here and cut this little edge here. This is the edge where the piston is rubbing. So I want to come through and just give that a skim, but I don't want to go too much because I don't want to run into my valve seat there. I just want to take this little bit at the top off just through here, and then so the piston can go a little bit further in there and I can up the compression a bit more. Now, because I did the piston first, so I can put it in here and try it. It's not much point doing this without a fucking gauge. Always want you to have yourself a gauge. So I might set up my little camera here and you guys can watch me make the first little cut here, and then I'll play around with it and make it fit. Alright, it's going to be too hard to put my little tripod up, so I'm going to do this one hand as best as I can. So I'm just going with a round insert tool. You see this little guy here? Just so it doesn't really matter what angle I'm cutting it on, it's got a round cutting edge. So I'm going to do this. I'm doing 2 things at once here, so just bear with me. So where is that bitch cutting? So, oh yeah, sweet. So it's cutting on that edge that I want it to there. So what I've got set up here, I have my tool post on a 45. So when I'll make sure I don't crash this. When I fucking turn this, cutting on a 45. So I'm cutting this edge off on a 45, and I use my round insert so that it doesn't really matter what edge I'm cutting on. With a normal conventional cutter, you have to cut in a direction. With a round one, it doesn't really matter. It also leaves a nice chamfer on both sides. So you're not doing a really aggressive, sharp cut. So I'm just gonna keep going with that. I'm gonna use my piston as a gauge, just gonna put it in there and see where it rubs, and just keep going until I sort of come close to my little valve seat there. So I'm gonna keep going and we'll come back when I've done it. Righto, so I pretty well cut out as much as I can through here without digging into my valve seats. So I don't want to really cut into the valve seats in case they come loose or something stupid, but you probably see a bit better from this angle. The chamfer that I've put on here, got rid of that sharp bit and put that nice chamfer on there. So I did a little bit of crude measuring. I reckon I got the piston another 50 thou up in there, so that's quite a lot, probably 50 or 60. So that is quite a lot. So I'm pretty happy with that. I'll put it beside the other one so we can get a bit of a comparison. All right, so it is pretty obvious the change in it. You see how that big chamfer there that I've put in there? And obviously this still just got a big sharp fucking like a right angle there. So it's sort of obvious what, you know, I'm trying to achieve here. If we have a look at the pistons, like I said, I did some crude measurements, and it's about 60 thou lower these pistons get in it, which is actually a fucking country mile. So it's actually quite a lot better. Let's see if we can see this just by the, oh yeah, it's pretty, so you can see, so see that's our second ring there, and you see how close that is to our gasket surface now. And if we have a look at this one, let's set this up a bit better. You see we can still see that first ring, and the second ring's all the way up there. So see how much deeper that is? It's pretty obvious when you look at it like that. The piston has gone down a heap, which is really what I need, because it doesn't really matter how far that ring goes up in there, because the barrel goes the whole way down here up to the ring. So the ring never comes out of the barrel. So we can be all the way in there like that. So basically all I have to do left, I'm gonna go through, do exactly the same on this head, machine all that out. And then once we've done all that, I'm gonna give these a good clean. I'm gonna go back over there to our assembly bench, and we are gonna assemble these things and see what sort of spaces we need under the barrels. I'm guessing we still need something. I'm just not sure how much. So let me do this to the other side, and then we will get to that. All right, so what I have going on here, basically all I did was I just threw my pistons in my barrels. I put a single base gasket underneath the barrels, and then I've sort of bolted it half together, so we sort of get a half idea what's going on here. Now I did both cylinders because I'm working with a pretty close tolerance now, how close these heads are to the pistons. I want to do it on both so I know what's going on with both cylinders. Basically on a stock application motor, stuff isn't as close, so it doesn't really matter. You can sort of just do one head and then the other one will be alright. With this one, I just wanted to make sure that because we have machined out our combustion chambers here, I just want to make sure we have the same clearance on both cylinders. So I've set them both up like this. I've already had this together and sort of sussed it out, but I'll show you exactly what I did. Basically, I have the piston at top dead center on this rear guy. So all I did was just rock this back and forth and just watch where the piston stops. So the piston stops right there. So that's as high as it will ever get. So Basically, the rule of thumb that I'm working to with this motor, they say you want about 40 thou of clearance between your piston and your head. Now, there's a few reasons why you want that. They say it changes with a few different applications, but I'll get to that. Basically, they say 40 thou of tolerance. So obviously, when these engines run, they get hot and cold. So everything expands and it contracts. But because we have different materials in this engine, they expand and contract at different rates. So basically, aluminium expands at one rate, and then we have steel barrels that expands at another rate. We've got steel rods, they also expand. And then we've got alloy pistons, which also expand at a different rate. So basically, we are given it that tolerance, so one might heat up at a different rate than another, making it bigger for a short period of time till it all gets the same temperature. One might expand less, vice versa, you never really know. So they say with a steel rod that you want about 40 thou. They say with an aluminium rod, not many people you're going to be running an aluminium rod in your Harley, but just for argument's sake, they say with an aluminium rod you want 60 thou. So they must expand differently when they're heating up or at temperature or whatever. So we're going to go for 40 thou. Now, an easy way I like to do this, these are not the head gaskets that I'm going to run with this motor. I'm going to run some Combustion 3-layer steel gaskets with this motor, but they're the same thickness as this. So basically what I'm working with here, this gasket is about 40 thou. So this is the gap we want. So an easy way to work out our 40 thou piston to head gap is basically just use this as a shim. So when we put it together like this, the head can't hit the piston. So when the head is just missing the piston, we know that when we put our head gasket in, we're going to bring it 40 thou away. So we just use it as a no-go gauge, basically. So this is the front head. If we put the rear head on without the gasket, we're just going to look what sort of gap we've got. So, see that? The piston is just sitting on the head, or the head's just sitting on the piston. Now, like I said, I've already done this. So, all I did was, I got two sets of feeler gauges, right? So we put one on this side, and then we put the other one on this side. So I'm feeling how much gap that I've got here. So I have about 30 thousandths here. So 30 thou gap is how much I've got here. So that tells me I need to put 30 thou of shim underneath my barrel so I can bring it up till the piston is just missing the head. So then when we put our head gasket in, we have said 40 thou of clearance. So basically, I've spoke about this whole episode that I want to run a stroker plate, but now that I'm only talking about 30 thou, another gasket is 30 thou. So this is said base gasket. They are exactly 30 thousandths. So what I'm going to do, it's not really, you want to run a gasket and then a stroker plate and then another gasket. I'm just going to glue two gaskets together and make it a 60 thou thick gasket. It's not the best way to do it. I probably wouldn't do it with a customer motor, but I will do it with my own motor because there's an issue down the track. Obviously, I'll fix it, blah, blah, blah. I don't really want to send a customer out with an engine that might have an annoying issue like that. So what I'm going to do with this motor is run two base gaskets on it, and then we should be fucking gravy. So basically what I want to do, the front cylinder is exactly the same. I've got 30 thousandths gap, exactly the same way that I've done this, so that I know both of them should miss when I have a 30 thousandths extra base gasket under there. So what I'm going to do now, I want to put another base gasket under both heads. I'm going to put head gaskets on, tighten it all down, and then I'm going to rotate the motor and make sure, reverse that. I'm going to put 30 thousandths base gaskets on this, and then without the head gaskets, I want to bolt the heads on and make sure they miss. If they miss without our head gaskets, then when we put them on, we're going to have said 40 thousandths clearance. So I'm going to go through and do that, and then when we come back, we'll see if they hit. If they don't hit, I can basically put this bottom end together and just the barrel. So as I said, I'm waiting on my Cometic head gaskets for this because I want to, like I said, I'm going to be running a bit of compression in this. That's the next thing I want to look at. Once I have worked out that 2 base gaskets fit this, I want to put a head gasket on and measure our compression. Like I said, I want to shoot for the 9 to 9.5 to 1 compression. So basically the higher I can get, the closer to 10, the better, basically. I know it's probably going to be a prick to start, but an economical motor will make more power, it will run more efficiently, and it will, enjoy life a bit better. Compression helps combustion. So more squeeze means more boom. So that's what I want to do here. So let's go through, put another base gasket in this, make sure our pistons don't foul the heads, and then we will get to measuring our compression. So come back to me in a sec. Righto, so you can sort of just see here, I have 2 gaskets under there. They fit pretty well, actually. I was a bit concerned about, they were a little bit different, but fuck. They're not exactly the same brand. One's a fucking James and the other one's a, I don't even know, whatever the fuck that is. But anyway, I have a tiny little bit, you can probably just see some air through there, just there. So it's under 10 thou. It's sort of hitting it and just popping it up under 10 thou. But from what I was reading, they say in fucking race applications and stuff, they fucking can go a bit smaller and go sort of to the 30 or 25 thou. So I'm pretty happy with that. Like I said, if this is a customer motor, probably not my own motor. I'm happy to try stuff. That's how you learn stuff, how you learn what to and don't do. So I'm just going to run with this. So what I'm going to do now, I'm going to put a head gasket, actually reverse up. I'm probably going to do this in the motor. You've seen me do most of my compression testing with the cylinder off the motor. I want to make sure the valves are in the right spot to line up with the valve pockets. So this, once again, is being my motor. I'll just put some ATF in there and measure it. So if it fucking leaks down into here, into the case, doesn't really matter. ATF's not going to make it rust. So I'm going to check the compression in the engine as it is. So what I'm going to do, I'm going to take this barrel back off. I'm going to put a ring on the top, grease it up, put it to top dead, put this head back on, and then I'm going to lean this motor over, and then we will fill up our spark plug hole, fill the chamber up, measure it, and we'll see what sort of compression we're working with. So I'll come back when I get this thing set up. The motor ended up actually sitting here by itself. It's actually quite solid. So a little trick for young players, you can just sit your motor like that. As long as the spark plug hole is like horizontal, it's going to fill the chamber up completely anyway. So basically what I got Reese's daughter's little Panadol fucking medicine cup here. Reese is the dude I live with. He's got a 6-year-old daughter, and this is what she usually takes her medicine with. She's going to have to find another one now, unfortunately. But generally, these are around the 80cc mark. So I'm sort of hoping mine's a bit less, but at the same time, I've got more stroke. So I'm saying it's probably going to be pretty similar, and then the stroke is going to make up for the compression. So I'm just going to start with 40. So here is 40 milliliters. Like I said, just with a bit of red Dex there. So, it's not going to fucking bother. It's not going to rust or nothing like that. So there's 40. Like I said, it's usually around 80. So start with a 40. Let's have a look in there. Can't see it yet. So let's do 10 milliliter increments now. So 40 was the first one. This will be 50. So we only need to do it to the bottom of the spark plug hole. Obviously there's going to be a spark plug in there. So the spark plug is going to be taking up some volume. So it's 50. Let's do 60. Taking this stuff out is going to be a bit more messy because I can't tip it over and pull it out, but we'll work it out. So that's 60. Oh, I can just see it starting, so we're getting close. Let's go 70. So that's 70. I reckon this will be probably getting close. It's just at the bottom. I'm going to go 5 more, so 75. The problem is you go too much. You can't really tell how much you've gone too much. So you sort of need to make sure you go less rather than more. So that's 75 cc's. No, a bit more. I think I said around 80, didn't I? So this is 80. Oh, that's a bit much. Yep, that's 5 again. So this is 80. Probably go a bit more. So maybe it doesn't have as much going on at the top, but like I said, we've got 1/4 inch more stroke than what we usually do, and that's going to add up to quite a lot of volume. So that's 85, I think. Yeah, 85. That's it there. We got 85 cc's of capacity at top dead center. So we need that to work out our compression ratio. So 85 cc's, sweet. So let me pull this shit apart, clean this crap up, and then we will get a pen and paper and work out what compression ratio I'm working with here. All right, so this is pretty well what I've worked out. So let's just go through this quickly, right? So the stroke we know because that's how far the piston goes down every cycle. We know that because this is the Evo cranks that everyone remembers. So they are 4 1/4 stroke. Now, because I am running standard 80 cube shovel pistons, we know the barrels are 3.5 inch. They're like 3.49 something, 496 or something. 3.5 is close enough, whatever. So our unswept volume, that's what we just measured. So that is the volume in our chamber when the piston's at TDC, like it is now, top dead center. So that was 85 cc's. So the swept volume, so that is the amount of volume with the piston at bottom dead center. So the top dead center to bottom dead center we know is 4 1/4, and we know the stroke, so the stroke and the bore. So just put that into a volume calculator on Google. Yes, you can do that pretty easily if you are a bit smarter than me, but this is fucking 2025. We got calculators everywhere. It's easy just to put these two measurements into a calculator and it'll spit out your answer in cc's. So we've got our unswept volume, which is 85 cc's. We've got our swept volume, so that is all the volume top to bottom from the piston. So that is our 670 cc's there. So what we do, we add these two together because when the piston's all the way at bottom dead center, you've got that volume and then you've got that little bit of chamber in the top as well. So you've got to add those two together. So 755 is our volume all the way at the bottom. And then we divide our 755 by our 8T5. So that is bottom dead center. So that's the piston all the way at the bottom. We divide that by top dead center. So those are the two volumes, and that gives us the compression ratio. So 85 goes into 755, 8.9 times. So we're looking about 9-to-1 compression here. So that's pretty sweet. I don't want anything crazy with this. Like I said, I want to ride this a bit. So I don't want to go any more than that for the time being, just because there's a bit more fucking around that has to be done, and it's probably going to be a bit more highly strung, so we won't do that. I'm happy with this 9-to-1 compression. So we got plenty of stroke there and a good bit of compression. So let's stick with that. I'm happy with that. So basically all I can do now is I can sort of finalize this barrel and pistons in my cases here, because I've ordered a gasket kit. This is not my gasket kit. This is Travis's gasket kit. I have just borrowed these for mock-up purposes. I've ordered my own, and that is on its way. So I already have the base gaskets for this. So basically what I'm going to do now, I'm going to pull this thing apart. I want to paint my barrels. These barrels have been painted silver in the past. I want mine black like that. I prefer the black. Silver makes it sort of look more like an Evo, because obviously Evos have silver barrels because they are aluminium. So I want to paint these black. So I'm going to pull these apart, paint these black. Once they're dry, we're going to come back, put our pistons and rings, lock all this down, finalize the pistons, and then all I'm doing is waiting on head gaskets, and that will pretty much finish up this episode. Alright, so since the last clip, I have gone through and I have painted all my barrels and everything. They look super nice. I definitely prefer a black barrel just because, I don't know, they're old. Why not paint them black? I don't like them silver, and we're not going to paint them some fruity LGBTQ color like red or something like that. But anyway, I have pretty much everything oiled up here. I have the rings on my rear cylinder. Obviously, I have the pistons all clipped in, ready to go on this thing. I have my base, where my base gaskets go, I have that clean. So I've gone through, and obviously we want to run 2 of our base gaskets here. So I've gone through, I have my 2 rear base gaskets here. I want to go through and glue these together just to, whatever, give them the best chance. These things are renowned for base gasket leaks at the best of times, and obviously I'm doing something that's not recommended and putting 2 base gaskets on here. So why not give it the best chance possible, and I'm going to go through and I'm going to glue them. So like I said, I have everything cleaned up. I just want to go through and put a little film of oil on this guy. So, little film of gasket maker on this guy. So this is just like an RTV gasket maker. Now, I don't want too much on here. If I put too much on here, my fucking oil galleries and stuff are gonna get full of glue, which we do not want. We would much prefer those oil galleries to work. If they're full of glue, they will not function correctly, and then we might, starve the top end of oil or something just because we've gone through and put too much glue on this bitch. So just like the grease, I'm just like going through and just making sure it has like an even film of this glue on there, this RTV gasket maker. I'm really not putting much on there. So next thing is just making sure that I put it on the right way. I don't really want oil on it, nor do I want too much glue on my piston or rod. So that's 1. Make sure I don't have fucking oil on my hands after touching that. 2, so let's go through, do exactly the same thing with this guy. I'm not sure if I'm gonna fast forward this right now, but you guys will fucking see. But basically, you can do this if your engine, like if its base gasket surface is not red hot, like it's got corrosion, or maybe the barrel's rusted on top of it, or maybe your cases aren't a perfect flush fit. You can go through and do this on your base gaskets if you're worried about them leaking. Because these fucking stupid things, what was I going to say? Because these silly things are renowned for base gasket leaks, and you have to take the whole top end of the motor off to fix it, it's pretty common to have people glue these things all the time. Even with a nice base gasket surface, you will see people gluing them anyway. So, it's not the end of the world. Sometimes it helps. It's all fucking builder preference, really. If you feel like it, you can. If you don't want to, you fucking don't have to. So, Base gaskets glued. So now I go through, put my little spring compressor on here, make sure they're in the right order, maybe get a bit of this off there. I've got a bit of glue on there. Not that that is going to stop much. A bit of glue is not going to stop the piston, but just to be nice and clean, I'm going to go through, put a little, I'm just putting the tiny bit of oil on this because if we put too much oil on it, it's going to drip the oil onto those base gaskets that we just fucking cleaned and glued. So I don't want to fucking drop oil on that because where the oil is obviously won't seal. So let's see how this goes with my Combustion pistons. Righto, so let's see how this goes. Main thing is putting this guy on the correct way. This is not something I want to do more than I have to. Come on, come on, this is a good start. Yeah, boy. Alright, so I nailed that. Let's just nail the rest of this. Hands as hammers. Boom! That is friggin' that. So the only thing I have forgotten here, give me 2 seconds. Now I didn't want to put this anti-seize on before I glued it because if this fucking anti-seize gets anywhere near that glue, it will fucking never work. So usually you just anti-seize this before you put the barrel on, but like I said, I want this glue to fucking work. So I have my little spring washers to go on the bottom. These early motors are supposed to have spring washers. Your late shovel stuff has the triangles. So I was never really that into correct stuff, like it being correct, but fuck, if you got the right shit there, why not put it where it's supposed to be, you know what I mean? Like, I've got the freaking washers there, why not just use them? So these are what's supposed to be on this motor, so it's what's going back on this motor basically. So that's pretty well, you know, putting the cylinders on. That's how I'm gonna do it. So I'm gonna do the same. I've already put one on that, you fucking spanner. I'm gonna do exactly the same thing on the front head. I want to tighten these down just because I've got glue going off there. I don't want to just leave it, you know, go off without pressure on it because it's going to be too thick then. I want it to be the 60 thou it's supposed to be thick. So 2 gaskets with 60 thou thick. So if I leave this for too long, maybe the glue will set and it won't be that. So I'm just going to go through now, tighten these down, and then I'll go through, put our front barrel and all that shit on, and then we'll come back and have a look at it. I took a little bit more off my piston off camera, so let's see with it all bolted down, set it done, whether it still lifts the head a little bit. So come back and have a look at that. So how good is this? So this is basically the whole bottom end and barrels and everything of my personal Panhead finally together. It's fucking crazy to see it this far after it's just been sitting around for so fucking long and there's just been roadblock after roadblock after roadblock. It's fucking good to finally see it halfway together. So basically all I've got to do left is slap the heads on. Like the heads have already been serviced and everything. I've machined them and everything. So literally all I got to do with the heads is put all the rocker assembly on and all that sort of bullshit. Put the tins on, which I have. The only things I don't have are the little D-rings. I think Ben's got some. I might steal them off him. But I'll just get some of them. I think Travis might even have a spare set. I don't know. Anyway, I'm going to have a look. That's really the only thing I need left to put the heads on. And the only thing I need left to finish the whole motor, I just need push rods. So I just had to buy some of these push rods for Travis's motor. So it's exactly what I'm going to need for my motor as well. So next time I do a JP Cycles order or something like that, I will buy some of those push rods for my engine. And then the thing is pretty well fucking done. This is probably going to be the last engine assembly video you see in my Project Pan series, because the engine is pretty well done. I might do with something on the heads and putting them on, or something when it's finished, but basically I need to get going on the chassis for this fucking bike. So I need to get going on, you know, putting that together. I've ordered some rear brake stuff. I have a rear mechanical drum and like all my brake linkage and all that shit already here. So I just need to go through, get the bike, get the rolling chassis pretty well together. And then I have a gearbox in pieces I need to do a full rebuild as well. So it's actually Ben's old gearbox case that was cracked and absolutely fucked. So I'm going to be rebirthing that fucking thing. So like I said, this is probably going to be the last episode on the engine. It's pretty well together, right? It's pretty well all there. I'll probably just do the next one putting the heads and shit on. So once again, guys, thanks for watching. If you guys have fucking learned something, I've got some links in the description below. You can go and buy a shirt. I've even got a buy me a beer button. So if you guys don't like the design, or maybe you can't be fucked paying for it, you can just buy me a beer. I'm always in here in the afternoon drinking a beer, working on my own stuff. So if you want to support that, it's much appreciated. So anyway, like I said, guys, that is it for this episode. Thanks for watching. Hope you learned something, and I'll see you next week.